Good morning, everybody, and welcome. Thank you for tuning in to the webinar today. We're going to be presenting for the first 20 or so minutes, and then we'll try to leave some time at the end for Q&A. And you can send us your comments, questions via GoToMeeting or just speak them at the end. So moving on to the introductions, my name is Lynn Pausic, and I am principal of Expero Inc. And my background is in user experience design. And with me today,
hi, I'm Sebastian Good. I founded Palladium Consulting about 15 years ago, and have been writing interesting custom software ever since.
All right. And you'll get to hear more about our war stories here as we go through our presentation.
So I've been doing, with my company, custom software development, a lot of architecture consultation. In the last few years, of course, along with everyone, we've been focusing more and more on distributed software, but really where we've made our mark is working on high-end scientific software, economic calculations, 3D visualizations, especially in the oil and gas space, but also in other industries.
Great. And this is Expero. Our focus is on user experience for what we call complex industries and domains. And we have been fortunate enough to work closely with Palladium over the last few years in a number of domains, oil and gas being one of them, where we work on these more complex UX problems where sometimes we're dealing with very large data sets, sometimes not so big data sets, almost always domain expert end users. And as a company, we focus on many different industries. These are examples of some of our clients. We have clients of all shapes and sizes, many different industries. Okay, so these are some of the topics that we're going to talk about today, starting off a bit about user audience, a little bit about the problem space, and then how to tackle the problem space from a UX and architecture standpoint. And when I say problem space, to be clear, big data is obviously a very thorny and challenging topic. We're not proposing that we have the answers to everything today, but we have some unique learnings and approaches that we wanted to share. So being a user experience focus, of the holy grail of what you always want to start off with whenever you're thinking about how to create any sort of technology is our users. So that's what we're going to start with today in our discussion. And so who uses big data? And specifically, today we're going to focus on the aspect of visualizing big data. So today, this is really the stuff of data science still, although unwittingly, we all encounter big data around us all the time. Often, a single number, statistic, or something we see is indeed the result of a lot of crunching and heavy lifting that has happened across many different types of data sets, and a lot of messiness is hidden in that capacity. And we're all consumers of big data in a way. In terms of the enterprise and in these more complex domains that we play in, today that's the stuff of data scientists, but in the future, in the not distant future, it's already happening. We're putting these visualizations and this type of analysis in the hands of many different kinds of subject matter experts. And so over there on the right, we have an example of a subject matter expert in agriculture. And this is very real. These are the types of things that we work on and that are happening out there. And it's interesting because we're exposing these subject matter experts who are not data scientists to a wealth of information. And as UX, we certainly have our work cut out for us to try to figure out how to make this information useful and consumable to these subject matter experts that need to think and use and act on this data, who don't necessarily have, most of them won't have a statistical background. or a data mining background, or all those things that a data scientist might have expertise in. So this is where things are headed. So we have some challenges and some gaps to close there. Another thing to think about, so once we think about who our users are, which could in the future be very broad, some typical things that people want to do with big data, and particularly, again, today we're focused more on the visualization aspect. So these are the kind of some of the big buckets that get talked about a lot. And we did not invent these. You can see I've got some references there at the bottom. But generally, people seem to want to explore. So there's this idea that you explore the space, you explore the data set, you get an overview and a sense of what's there. So they're kind of in this exploration discovery phase with the information. Sometimes people come for explanation. So people come with an open-ended question. Something like a big thorny question, like maybe if it's a business intelligence tool of sorts, where does most of our business come from? Well, that's actually a big thorny question that requires converging a lot of different data sources, and so this heterogeneous data is a real common problem that users will run into in the future with big data that, again, we have to figure out how to deliver in the most sensible way. But they might be searching for an explanation. They've seen something unexpected. They want to further understand what's happened. And then this third category, this is a category that Stephen Few, for those of you that might be familiar with him, he's kind of the canonical read in UX when it comes to displaying quantitative information, sort of the next generation Tufty. But he talks about variance and watching out for different kinds of variations in the data. So there are routine variations where it's expected, and then there are these exception cases where it's unexpected. And so it's interesting when you think about big data, there's a lot more opportunity for variation to be the norm, but variation that's bounded. And so that's another thing that people will often be tracking in the data. And all this, I have a quote over there to the right. For those of you that might have a UX background, you may be familiar with Ben Schneiderman and his mantra that data scientists often refer to, that was laid out back in the 80s. And it still really holds true today in how people are approaching big data in UX. And that is, first, you're going to do this overview and you get a lay of the land and what's there. And then you need to be able to get in and also quickly zoom and filter and sort and sift and get at those details. But that's been around for a long time, and he's kind of a great read in that area. Some of his insights from the 80s still very much hold true today when you apply them to big data. So it's interesting in terms of UX, not all very large data sets, in terms of how you visualize them, there's not always a new paradigm required. Sometimes there's a whole lot of lifting that has to go on the back end in order to manifest, something simple, relatively simple on the front end, although, the way it manifests is simple, but there's a lot of convergence that needs to happen between different data sources and things to display something as simple as an indice, for example. A lot of dashboard and a lot of trend-based information. A lot of that still works very well for big data, so not everything requires a new paradigm. Being able to interact with georeferenceable data, so drawing, say, an arbitrary polygon or something on a map is a way of querying a whole lot of data on the back end and surfacing that on the front end of what's available. These are all things that can be very simple ways for allowing users to interact with large data sets. Sometimes this is where we start to get into gaps. Might be necessary to expose users to a little bit some different types of things that they may or may not be comfortable with depending on their background. So the stuff where you start to tread on that data science category, getting into things like, for example, here, frequency, and we have a histogram here. Where we're looking at big macro trend information to get to, say, a map view here on the right? So starting to introduce a little bit of the stuff of statistics and data science tools to end users. And that's going to be a challenge for UX and interesting to help educate users how to use some of these tools to bridge the gap. Just like other disruptive technologies and paradigms that have come along, there is going to be a gap to close here. And so there's going to be a little bit of education uplift required for users, but it's not solely education. It's also on us to create experiences that are going to help the user sift through and navigate as effectively as possible. One of the things we like to talk about when we talk about, yes, of course, you need to understand your users. We like to talk about mind melding with your users, really getting inside their heads, and that is understanding, not just if you have a piece of software today, it's not just about how they flow through the software. With big data, it's really getting at what the types of questions are that users want to bring to bear on the data, right? So they want to be able to answer certain questions. They have certain expectations about maybe how they're going to answer that question. They might be used to a certain sequence of events that they go through today across many different sources to gather the information they need to answer a question. So there might be an expectation there that you need to support. The type of interaction that's expected, are they expecting a very fluid type of interaction with the information, or is it one where they are willing to interact and then get some information back over some period of time, right? So something that runs in a batch job or in a background task or that sort of thing. And then ultimately, what do people want to do with the data? So when we're mind melding with our users, and by mind meld, there's lots of different ways you can do that. So you can do surveys, you can do user testing, you can do focus groups, you can do ethnographic studies, so watching people and how they work and see the types of things that they want to do with the information. But it's always been important in UX to understand our audience. And when it comes to being able to get the value out of interacting with these large data sets, that's even more important if you're not already doing that. There's also a nice intersection point here for making our user experiences as useful and usable as possible when it comes to big data. And that is the intersection point of understanding our audience and then the art of the possible on the back end. So if a user is interested, in a certain answering a certain question, let's say they're interested in something that requires a temporal aspect to the data. Well, do we have that available on the back end? If so, how can we expose that? What are the expectations around performance on the back end? How can we architect it to meet those expectations? Is it even possible? How fast can we deliver? What kinds of clever things can we do on the back end? I don't know, Sebastian, if you had anything to add on this.
Sure. I was to say, unlike a lot of traditional application design where you can stuff everything of interest in a relational database and get answers back with moderate work, these big data sets can require specialized tools and may be so large that they can't reasonably produce results in the time that you want. So you need to work closely with your architecture team, more so than with small data sets, to get a level set on what's even possible. And need to understand what kinds of new tools are being rolled out to work with data at this scale. Obvious examples are graph databases from Google or Facebook, but there's others out there. And this is really the time when you're dealing with lots and lots of data and trying to distill it down to something small a user can understand. It's the time to engage with smart scientists and computer scientists, because the right algorithm, the right statistics can mean the difference between possibility and impossibility.
Okay, so hopefully we're working with our users and we're trying to understand what's important to them, the types of questions that they're bringing to bear on the data. And there are many different ways to approach it. The one that we wanted to share today, one technique that we use, is something we call identifying the dominant dimension based on what we know about how users want to work. So this is an example of a UI for a touchscreen application. And it's a touchscreen application that allows domain expert end users to browse sensor-related data In this particular case, this is set in a power plant, and the data overall is big, but it also can be quite small. So if we look at the entire landscape of the data that would be driving this user experience, it could be quite large. Yet if we carve it up in the right way, if we understand what's important to the user and how they think about most intuitively browsing the information, assuming the stars align and the attributes that make most sense to them for browsing also exist on the back end, we can pretty quickly pare down the problem. So if we look here, so with 400 terabytes per year, we start to look at browsing. We'll show you more detail in a minute. Chronologically, we get that down to maybe terabyte size, of course not on your client, but terabyte size data in a 24-hour period we might need to deal with on the back end. But then to get to the heart of the detail of what the user is really interested in once they find what they're looking for, it's actually quite small. We can take something very large, and once we understand how users want to work, we can carve that up in a way to deliver a really nice, fluid experience. Some of the dominant dimensions that we often talk about are listed here, and some of them also have in parentheses how they equate to some of sort of the more typical terms that you hear around big data with velocity and veracity and variety and volume, all the V's that go along with big data. So some of the dimensions that we encounter often in these types of problems are temporal, time-based dimensions, frequency, which can be just the sheer velocity at which the data changes or comes in. It could also be other types of frequencies that are a little more detailed within the data, rates of change of specific things. Of course, veracity, the overall quality of the data. Relationships can be very important, so connections, correlations, things like that. The context is very important. Big data is typically a heterogeneous mix of stuff, and you start to have these individual pieces of data get taken out of context and they lose their value in their meeting. So being able to preserve context as much as possible is important. The type or the variety of the data, the size and the volume, the state, sometimes georeference. Geodata comes in as well, and that can be a dominant attribute for browsing. And then, of course, there's always custom attributes in the data. And these are just some of the characteristics that we often consider whenever we're working with users to try to find, what is that sort of real dominant way at any given time that they want to browse the information. You can also pair these together, which I'll show you an example of in a minute. So in the example we were just looking at on our touch screen here, the dominant dimension is actually two put together. So we have time, and in this case we have an overall health indicator for these little red squares here represent individual sensors. And we're just looking at one small area. There are thousands of these little sensors available. And so we're pairing these two dimensions together, time and health indicator, as our most dominant way of browsing the information in this particular area of the UI. Now, in somewhere else in the UI, it could be that there are different dimensions that should dominate the user experience and how we're going to move through the data. But if we pick this as our dominant dimension, and we were talking about size earlier, the reality is to get to this moment, maybe we're having to deal with terabyte size data on the back end. But by the time we pare things down on the front end, so we take this dominant dimension, we apply another tool here. In this case, it's a lens tool that's going to allow us to visually filter based on location or perhaps some other characteristics of these little sensors. And then further, now we can get to revealing the sensor details on demand. So we've got this dominant dimension doing the heavy lifting. And when we get to these sensor details on demand, the data set is actually quite small. And although we're not showing it here interactively today, the interaction is also very fluid. And this will get to some points that Sebastian's going to discuss later about these types of interactive visualizations and fluidity and the ability to have a reactive user experience where things feel very fluid. And we can traverse these large data sets and see this kind of information update real time. And that's due to the smart things that we're doing architecturally and staying in lockstep with user needs and what's possible on the back end. Another example of pairing a couple of different dimensions together. This is another touchscreen UI for biotech, and what the scientist user is doing here is they browse to a particular area of a molecular structure, and based on that context, the software is giving them some different possibilities from which they can choose to modify that molecular structure. So again, we're not going to walk through the whole thing here, but similar to the previous example, we've gotten to the point where we have browsed, we've pared down the information, and now for the user, it's not just location, but it's also context. Having that contextual information along with the dominant dimension is very important. From a UX standpoint, I'll say be careful. There's obviously a lot going on. There's a lot to manage when it comes to these large data sets. It's very easy to get distracted and get caught up in the technology. What we really want the focus to be is where we started with our user audience. What are their goals? And keep in mind, as your guiding principles, what are those questions, those big questions that they were bringing to bear on the data set? That's really what we're enabling. So try to stay within the guardrails and not get distracted. I'm going to turn over to Sebastian, and he's going to talk some about how you enable from an architecture standpoint and some things you can do to enable these reactive user experiences.
So we've found that once your data sets get big enough, you can't really fake the back-end architecture. So I've brought 5 topics to talk about today, each of which frankly could be its own seminar. But it gets to the art of dealing with big data to know what's possible. Often a user experience designer will tell you what they'd like to see, and you just go make it happen. But when your data set gets big enough, there has to be a conversation back and forth about when you can or can't do something, or when maybe you need to do some research to answer that question. So first we need to know how big your data is. It can be measured in a number of different ways, but for visualization, it's important to look at how big it is in relation to how quickly you can get an answer out of it. I'm going to outline a few of the approaches we've used in the past to size problems for big data sets for both general computation and interactive visualization. So first, speed limits for human interactivity. What is built into the human body? What do we actually have to accomplish? First thing we discovered is touch and mouse interfaces rely on an illusion that your fingers and hands are moving something real. That's why your 1-year-old can figure out an iPad. We're a very agile species. We can do microsurgery, we can throw baseballs. We can't be fooled by a touch interface that moves much less than about 60 frames per second. If you've ever noticed how hard it is to move a mouse on someone else's screen through a GoToMeeting, you'll understand why this is, because it breaks the illusion when the network travel time gets greater than those 15 milliseconds. So if you're building one of these apps and you want to move a widget like that time slider Lynn was showing in response to a human movement, you have a 15 millisecond budget, which is not really very long. We also have excellent eyesight. It's attuned to movement and depth, and if you're animating a scene or a report, 10 frames a second is really about the slowest you can go without frustrating your visual system. 60 frames is better, but 10th is about what you can do. It's also your budget if you want to provide an instantaneous response, so the user feels like she's exploring something completely interactively. This speed kind of activates the exploring and hunting part of your brain. Now, how long before your user decides to check his Facebook account? Apparently you have about 1 second, maybe more if they're disciplined. If you can give them an answer that quick, it's not quite fluid, but you can keep your users in a zone without breaking their concentration. They can try lots of ideas and still make progress. You'll notice that Google almost never gives you a response that takes longer than a second. Even your most disciplined user can't keep deep concentration for more than 10 seconds. So at this point, you really need to consider telling your UX designer that you need to move away from an interactive or exploratory workflow towards a batch workflow, where the user may put together his instructions, execute some jobs on the back end, and then look at them later. So these are the key time limits. Now let's look at size limits. Let's take a physical dimension. I chose 20 terabytes for this presentation as, quote, pretty big. It's a day of cable TV in the US. It's one extremely large seismic data set used in oil exploration. My understanding is it's about 1 or 2 days at Twitter. There's a hierarchy of processing and storage hardware at your disposal to work with this, all the different price points summarized in that table there. And the insight that's maybe most critical to understanding how to deal with it, accessing that data in order, if you know the question you want to ask, or out of order, randomly, if you don't know the question you want to ask, makes a huge difference. It's clear most companies can't afford to process this much data truly interactively, but they come up with it all the time. How do they work with it? Tricks are pretty much the same everywhere. Crunch less of it, reorganize it, or get more computers. First, a little reality check. We've talked to some clients who say they have big data, and when we sit down and look at it, it's a few gigabytes. It's enough to have performance issues with if you're not careful, but it's not really big. I can rent a machine with a 1/4 terabyte of data from Amazon for $1.50 an hour. So think carefully about whether it's really big. But suppose it is. Let's consider how we get that big data crunched down into the speed limits we talked about. As Lynn mentioned, it may not be that big by the time a human can see it. The image on a brand new fancy 4K screen is only about 32 megabytes. And scientists who've hacked the human eye and visual systems say that you can't really take in more than 1 megabyte of information per second per eye in the first place. So if you're talking about processing big data into something you could look at, as Lynn said, the fundamental problem is reduction. So sounds naive, but it's quite effective. Here's an example from a client. It's a 3-dimensional image out of a 5-dimensional data set. Again, this is a seismic data set used in oil exploration in the Gulf of Mexico, including the dimensions you can't see here. It's about 20 terabytes. Now, the traditional approach used for many decades at these companies is to use a set of batch processing tools that would take the whole thing in, crunch it, spit it back out, and then use a general purpose program to look at your idea, however you've transformed the data set. And that's basically what you would do if you had Hadoop. If your answer to big data was Hadoop, that's what you'd do. It's straightforward, but if you remember the table from a few slides ago, that might take you a few days. But if you look carefully at this, how much of that 50 terabytes can you actually see? If you consider just the faces of the solid in that image, it's only a few dozen megabytes. If you can reframe the problem and retool your tool set to just calculate that data on the fly, you're cutting the work you have to do down by factors of millions. And so now you're achieving truly interactive exploration of dozens of terabytes of data. For our client, we did this at about 10 frames a second. That's differentiating. That's a different way of working. So let's decide you know how much data you want, how small you can crunch it. How do you figure out which of those human speed limits you can hit? You need to look at the rate limiting step. This is our first step when we look at someone's problem to figure out, bigger than a bread box, smaller than a bread box. In this case, we take that same data set, extract a fairly small but unpredictable part of it, then crunch it down to a small image, a few megabytes. That table shows you a variety of options we considered with assumptions about how quickly you could tackle that problem with different machines. The rate limiting step for loading your data up to look at is reading it from disk into your computer's memory. And the rate limiting step for looking at different realizations of it is churning it through the CPU to run some number crunching on it. So if you just kind of do some division, you can hand back to your UX designer, your product manager, kind of a scope of what's possible. With one really expensive machine, you could create a process appropriate for data scientists. She could load the data into memory over the weekend and then spend time interacting it with, in kind of an ad hoc way. Every minute or two, she'd have a new answer. With 30 machines in the appropriate backend, you'd have a process appropriate for nearly interactive work. You could load the data over lunch, and you could query it pretty often without derailing someone's train of thought. With something like 300 machines, you can do the work completely fluidly, animating the response or animating the result in response to a slider to unlock a different kind of user experience altogether. Consider also what pre-processing work may need to go into this. That 20 terabyte of data may only take 5 or 10 minutes to load once we fire up those 300 machines. But to turn it into a form that's suitable for what we did takes several days of pre-processing, which is another problem you need to solve. Not all computations are perfectly parallel. Not all computations can operate at the limits of the hardware that I've laid out here, but unless you do that computation, you don't even know what realm you're operating in. So this is always our first step. Second, let's say you can't figure out how to decimate your problem any smaller and you still like to give a good response. There's a surprising number of computation options that fall into the category of being nearly right but fast, rather than being exactly right but later. In other words, can you cheat? One example that we see all the time are images. They're compressed so well and our eyes are so good at fixing flaws in them that we usually forget we're seeing data that's been compressed by a factor of 10. It could well be that your data can be compressed, maybe even a lossy way like these pictures. That's not exactly precise, but is good enough to make accurate judgment on. Here again is a great case where you'd want to engage a deep domain expert or a statistician to figure out whether that's possible. If you can apply what amounts to a fancy math equation and cut down your hardware needs by a factor of 10 or 100, that's very much worth it. There's a whole family of algorithms, some of which are fun to show, that give you approximate counting. Do a search on Google and they'll refuse to admit exactly how many results you'll get back. In fact, as you page through it, you'll see they changed their mind. But it doesn't really matter whether there's 500,000 results for the J. Giles band or 512,000. And I'll bet you for a lot of questions in your data, it doesn't matter as well. A fun example that I find brings home this point is a data structure called the Bloom filter. It could be quite appropriate to the kind of sensor-based workflow we were looking at in that demo. Imagine you have a massive number of data points to categorize, but you can't use more than a certain amount of space to keep track of the categories. You may want to just track a few million categories so that you can hold them in memory, rather than billions or tens of billions, which would force you to use a disk. In the example above, we're just tracking whether we've seen someone with a given name by looking at the first letter of their name and marking a bucket as having seen someone with that range of letters or not. After seeing the first 4 names, we've marked 2 of the buckets as having data in them and 2 as not. Later, if you go ask whether Dave was in the data, you can only say maybe. Yeah, someone with the letters A through F was in a bucket, but you can say it really fast because you have a small number of buckets. If you want to know whether Madeline ever appeared in the data, you can say definitely not. There was no one with that letter range in there. So you're not getting an exactly right answer, but for your workflow, you may be able to process your data much, much faster if you're willing to tolerate some false positives. This is one of a whole family of algorithms like this, and if you give yourself permission to look at your data lossily like this, you may be able to decimate your problem much smaller than you thought. So what if even after you've decimated and you've cheated, your data is still 10 seconds big, but you would rather it be 100 milliseconds big? Well, if you recall from before, the processing times we have to face just from pure computer architecture, from in-order and out-of-order data, in other words, unprepared or prepared data, can differ by factors of hundreds of thousands. So if, as Lynn explained, you're looking at different dominant dimensions in different parts of your user interface, you may find that you need to transform. You may need to give yourself permission to hold multiple copies of it. You want to show sensors closest to the door, you're going to need a spatial index. You want to figure out what sensors failed within 5 seconds of the failure of any other sensor nearby, well, you'll need a list of readings ordered by time. So sadly, one of the ways to make your big data much smaller may be to actually hold even more copies of it, which you're able to access and index more accurately. Different dimensions will imply different copies, and not just because they're organized better, but because there's commercial or open source systems out there that are good at working with it. Tools that are well known to get performance that approaches the raw capabilities of the hardware can take years of engineering. And so if you can figure out how to recast your problem into a form that someone out there has already solved, and you're willing to give yourself permission to make copies of it to use their engine, that can be an extremely effective way to get fast results. As Lynn showed in the example, you may have to chop your data into pieces and just admit that they'll respond at different rates. So updating a few dozen or a few hundred sensor readings on the upper left side doesn't tax any sort of user interface because I can identify which they are with a fast spatial index. But if I want to scroll through an arbitrary history of data at a terabyte a day of input, I may need to keep several copies of it indexed by space, indexed by time, and I may need to decimate the heck out of it. I may need to make a business decision that the last few hours I hold everything, and then I start decimating data out of it so that it's much faster. So finally, you probably face a big data problem either because your data at rest is massive or you're getting huge streams of it. If it's huge and you need to meet your performance budgets, you probably divided it up into different pieces, different copies. Of course, if it's streaming, more of it's coming in at every moment. In both cases, your user interface needs to react to the data or the questions as they come. This is really a little bit different than just the sizing discussions I've had with you for the past few minutes. This is really about how the technical construction of your user interface changes when you're dealing with lots and lots of data sets. In a traditional design, the user asks a question, presses a button, and we wait to assemble all the answers from a database, and we show the results on a web page. Maybe one screen is updated, or one web page is sent, or one spreadsheet is downloaded. But if you have to embrace multiple copies of the data, or embrace multiple kinds of engines to query the data, you're going to have to embrace the fact that they'll respond at different speeds. Some of them may not be working at all. In this large touchscreen example, you may be able to show live sensor data by just subscribing your app to a live feed, but to manage the time slider, you're going to have to deal with 2 frequencies of events at least. The slider has to move fluidly, or it'll break that illusion I mentioned before. That means 15 milliseconds, and you've got to move the slider. But it's unlikely you can repaint your sensors to match that slider every 15 milliseconds. You may only get those results back every 250 milliseconds or every second. So your screen will be eventually consistent with the controls the user is moving, but it could take more time. We found in constructing this kind of application that training developers to build their user interfaces this way, to be graceful in the face of failure and in the face of multiple frequencies of update, requires a different way of programming than they're used to. It may require different support from your back-end systems. In the industry, it's called a reactive interface. And if you're setting out to build one of these, you may need to get some training in that area. So to round up, on the technical side of interacting with big data, we've covered some of the basic sizing mechanisms we've used to figure out how big your data set is, measuring in time and space, and how to convert between them with your rate limiting step. We talked about how to reduce the problem to be as small as possible given the speed limits that are inherent in how humans are built. We talked about cheating, how being approximately right might be much faster than being really right. We talked about how you might embrace multiple tools, multiple copies of your data, and how you're going to need to reorganize how your user interface is built from a technical perspective to make it all work.
All right, great. Well, again, thank you so much for joining us today. And if you think of any questions or would like to dialogue about anything you've heard today, do feel free to drop us a line. And
thanks for
thank
joining.
you very much. Have a great day, everybody.